Solving linear equations beyond the basics 4. A linear equation is an equation whose highest power of a variable is 1 when it's simplified and no variables are in the denominator or the bottom. Okay? So in this video, Beyond the Basics 4, we will discuss linear equations with a decimal in at least one term. And this may require techniques in any of the other Beyond the Basic videos or the Basics videos. So decimals are basically fractions. So when you have an equation with decimals in at least one term, you can solve immediately or eliminate the decimals first and then solve. All right? Again, I just said that decimals are like fractions. I eliminate my fractions first. I mean, sometimes with decimals, like the first example I have on here is going to be much, much shorter if you just solve it right off the bat than if you change everything and then try to change everything back and whatnot. All right? So it's more of a preference there than anything else. I don't want to say that one way is better than another way or whatnot. But you want to simplify both sides, move everything to one side, variables to one side, numbers to the other. Again, numbers not associated with a variable. And then for more help with this, solving linear equation, the basics are the other Beyond the Basics videos. All right. So here, x minus 2.2 equals 4.5. You can get rid of the decimals if you want to, or you can look at it and go, hey, both of these numbers just have one decimal, and all I need to do to solve for x is what? Move that negative 2.2. All right? Efficiency-wise, that's the best move. If you want a way that always works with decimals, I would move my decimal place one place, and I'd have to have a 10 in front of the x. It's basically moving it one place is like multiplying by 10, because that's 1/10, 2.2, 2 and 2/10, 4.5, 4 and 5/10. Okay? So, and if it's two decimal places, we call that hundredths, right, with a th on the end of it. Thousandths for the third decimal place, right, with a th on the end of it. Not thousand with a d like a thousand, a thousandth. Okay? So if we have that, then we would move the decimal place 3 places. It's like multiplying by 1,000. So something that didn't have anything would become 1,000. So here, because if I look at this, one decimal place and one decimal place, and all I'm going to do is move that over, that's what I'm going to do. Okay? So I'm just going to simply add 2.2 to both sides. And when you add or subtract decimals, you've got to line the decimal up. That cancels. X equals. Line the decimal up. Okay, that's got to be lined up. So now you can just do your regular addition rules. 5 plus 2 is 7. Keep the decimal in line when you're adding and subtracting. 4 plus 2 is 6. There was nothing to carry over, no 1, nothing like that. So x equals 6.7 there. All right, and then if we had to check it, if we had to check this, then how will we check it? Well, go back and say something minus 2.2 equals 4.5, and the something I'm plugging in is my x, which is 6.7, right? So I'm plugging in. So then 6.7 minus 2.2, and if you have to, come to the side and do this. Now on this one, it doesn't require it. This is pretty simple. 7 minus 2 is 5. There's nothing to borrow. 6 minus 2 is 4. 4.5. So this is 4.5 equals 4.5, and it checks out. 4.5 equals 4.5, and it checks out. So just to show you what it would look like if we got rid of the decimal, okay? Decimals are like fractions. It's exactly like a fraction here. So I would multiply if there's one decimal place. One decimal place is the tenths. So then I got to multiply everything by 10 on both sides, okay? So I'm going to say 10 times x minus 10 times 2.2 equals 10 times 4.5. So it's going to be 10x minus 22, because that means move the decimal place one place. 10 times it means move it one place, equals 45. Okay? So now I have no decimals. I'm going to move my 22. And guess what? I get 10x equals 67. Then I divide both sides by 10. And if multiplying by 10 means move the decimal place 1 to the right, guess what dividing by 10 means? Move it back one place to the left. And you still get 6.7. Typically, if you are given an equation with decimals in it to start with, you give the answer back in decimal form if it's not a whole number. Okay? You give it back in decimal form if it's not a whole number. So, and me personally, I don't want my students rounding unless you're told to round. Otherwise, if it gives you 4 decimal places in the answer, put 4. I don't care how many were in the problem. Okay, that's what I want. I want you to be exact and precise as possible. Unless I say, hey, round it to 1 or 2 decimal places or whatever. If you're dealing with money, right, money should always be rounded to 2 decimal places. You can't go in Walmart or some store and say, okay, here's 3.5 cents. No. If it costs 3.5, they're going to charge you 4. Right? You don't get that, right? And not anybody just saying you don't round cents off. If they're rounded off, they just round them literally. 3.5 and round up to 4. All right. So x equals 6.7 here. Again, I don't know that I would show times 10. I would just say, hey, I know that it means move my decimal 1 over. So I would say my decimal here gets moved over 1. I had a 1 point something, that'd be 10. That moves over 1 is 22. That moves over 1 is 45. Okay. I think I would just do that, moving it over as opposed to showing times 10 every time. All right. But on this particular problem, I noticed, hey, both of my things are just 1 decimal place, and all I'm doing is moving the decimal to another decimal. Just line them up and add them together. Put them on the other side. And leave x by itself. And sometimes if it's just x, like if this is just x, I may just deal with the decimals along the way, as opposed to changing them and going back. Now, if that was 2.5x or 6.72x, okay, now I might move my decimals and get rid of that because I don't want to deal with all that coefficient of x with decimals. Right? It's okay we just deal with numbers with decimals, but you start putting in the coefficients of x with decimals, now it becomes a little bit more of a hassle. So here, this is basically the same thing. The y is by itself. Both the other numbers are 1 decimal place. You can move the decimal place 1 or multiply by 10 by everything if you want to, but here, the most efficient way to solve this one, noticing that y is already by itself, or not by itself, but just 1y, then, or no coefficient with the decimal, I'm just going to add 2.7 to both sides. So then y equals, again, my decimals are lined up. The signs are different. So is it going to be a positive or negative answer? It's negative because 5.3 is bigger than 2.7, and then I come out here and say, okay, you can do it right there, but what is 5.3 minus 2.7? Well, I got to borrow, make a 13 here and put a 4 here. I'm going way old school on you right here, right? I mean, way back to first grade when you learn how to subtract and bar stuff, or second or whenever it was. All right. So 13 minus 7 is 6, and then 4 minus 2 is also, 4 minus 2 is not 6. 4 plus 2 is 4 minus 2 is 2. So 2.6 is your answer, and it's negative because 5.3 is bigger and it's negative, right? So y equals negative 2.6. Y equals negative 2.6. And then here, x plus 1.13 equals 6.2. Here I have 1 decimal on the right side and 2 decimal places on the left side on the longest one, right? So now I would move everything 2 decimal places. And if I did that, I'm not going to do it on this one, but if I did it, I would say 2 places, that's 113. This is like 1, move it 2 places, that's like what now? 100x equals, move it 2 places, you got to put a 0 there, 620, okay? If you did that, that's what it would look like. I'm going to choose not to do that here because why? Because this is already just good old x. There's no decimal associated with the coefficient of x, so I'm not going to worry about trying to do that. And it's only 1x, one variable, 1x. So I'm going to go straight to subtract 1.13 from both sides. And notice I got to line my decimal up. That's not a 3. Got to line my decimal up, right? So over here, this cancels. X equals 6.2 minus 1.13. So what I'm going to do is come over here and do this subtraction, and it's going to be positive. 6 is bigger than 1. So then here, I put the 0 here, right? I added that. Now I need to borrow, make this a 10 and borrow this and make a 1, right? 10 minus 3 is 7. 1 minus 1 is 0. Didn't need to borrow anything there. And then 5. So 5.07 would be my final answer. X equals 5.07. X equals 5.07. All right. 1.2x minus 2 equals 2.8. I do have a decimal times my x, but I still only have the 1 term with x there. So do I want to move all my decimals or wait? I mean, either way. So what I'm going to do is I'm going to work it without moving the decimals right now, and then I'm going to move the decimals and work it. Okay? I'll work it 2 ways here. So first I'm going to say, okay, let me just add the 2 to the other side, and then I got to line it up. Line up my decimals. It's 2 point something, right? So line that up. That's going to cancel over here. 1.2x equals, this is 4.8. 4.8. Don't let decimals trip you up. 2.8 plus 2, you're adding the 2's together to get 4, and you got the 0.8 still there. Then I say, okay, wait a minute, I got to divide. Divide by what? 1.2. And I don't like to divide by decimals. I think we were taught we shouldn't do that. So what I need to do is here, multiply the top and the bottom by 10. Instead of, like when you simplify a fraction, you take 10 out of both, or take 2 out of the top and the bottom, right? Here, put the 10 in. Multiply 10 by, that's going to move each decimal place one place. So that's going to be 48 over 12. Can I simplify 48 over 12? Yes. That's going to be what? 4. 4 over 1. Don't try to divide by a decimal. You don't want a decimal in the denominator. If you move the decimal place once in the denominator, you got to move it once in the numerator. So I'll move the decimal place once in each one. That's like multiplying the top and the bottom by 10. The numerator and denominator by 10. If I look at this problem and go, you know what? I have 1.2x to start with. I don't like that. I want to get rid of that. So I can take 10 times everything, right? So take the 1.2. I'm just going to write my problem down again. My equation. I'm going to move it over one place. 12x minus, move it over one place, got to add a 0, minus 20, equals, move it over one place. Moving it over one place is the same thing as multiplying by what? 10. I multiplied everything by 10. So if I move the decimal place in one term, I got to move it in every term that many decimal places, whether it's to the right or to the left. So now I'm going to add 20. I get 12x equals 48, divide by 12, and x equals 4. So there in orange, I gave you a different way to work it. This is more of a preference. You choose one way or the other, okay? I prefer when there's just one term with x to work it with the decimals in it, and then take care of it in the end is what I prefer to do. But I know sometimes it's confusing. Decimals are confusing sometimes, but they're just fractions, and one decimal place is times 10, 2 is times 100, 3 is times 1,000, and you always go with the most decimal places. You don't do the 3 decimal place times 1,000 and the 1 decimal place by 10 in the same problem. If you choose to multiply one term by 1,000, every term's got to get multiplied by 1,000, which is the same thing as moving the decimal place 3 places to the right if you multiply by 1,000. All right? So here I move them all once to the right, it's like multiplying by 10. 1.2 m minus 3.6 equals 2.4 minus 0.03 m. Wow, this is a bunch of decimals. And I have multiple terms with variables in them. I'm most likely getting rid of the variables first here. You can do with the decimals first if you want, but I'm definitely going to get rid of them. How many decimal places are the most decimal places in a term? 1. They're all one decimal place, which is really nice. That means I'm really multiplying every term by what? 10. And I'm going to move it over one decimal place for each term. If I do that, that's going to be 12m minus what? Oh, there it is. Going over this craziness. 12m minus 36 equals 24 minus what? 3m. Decimal place just moves over once. Now I don't have a decimal anywhere in that equation. That's great. So now I just solve it. What do you want to move? Well, again, you can pick any of these 4 things because the m's are not one apart. I'm going to move the negative 36 and add it to both sides. If I do that, that cancels. 12m equals, that's 60 because in my head I did 20 and 30 is 50. 4 and 6 is 10. 50 and 10 is 60. Minus 3m. And then now there's a best move, and that's to move my m's to the right. So I'm going to add 3m to both sides. That cancels. I get 15m equals 60. And then I divide both sides by what? 15. And m equals 60 over 15 is exactly 4. I don't need to worry about do I use one decimal place or 2 or 5. It's exactly 4. M equals 4. But again, if you're in a class and your teacher tells you if you start with one decimal place, the 10th, you better give me your answer in tenths, and you better tell them 4.0 if that's what they want. They're your teacher. Do what they want you to do. Okay? So let me erase that. I had a M disappeared on the last page. When things disappear, I have to go mark through it and mark on the next page and come back, and it usually takes care of it. So what I did here on this one, and I even think the next one, I just went crazy with some of these. 3.25D plus 7.62 equals 2.47D plus 8.01. I mean, really? I just went crazy with this. So how many decimal places are there? Well, the good thing is they're all 2 decimal places. So if I need to move everything 2 decimal places, that's like multiplying by what? 100. So move it 2 places. 2 here, 2 here, 2 here, and 2 here. So that's going to be 325D plus 762 equals 247D, plus 801. And now, what do you want to move? It doesn't matter. They're not one apart. The D's aren't. So you pick something. I'm going to move the 247D this time. If I do that, that cancels over here. 325 minus 247. So what do you think? Well, from 247 to 300 is 53, and then 53 and 25 more, that's 78. 78D in my head again. That's how I do in my head. Plus 762 equals 801. And then I need to subtract the 762 from this. That cancels there. From 762 to 800 is 38, and then one more that should be 39. And really, to get to 38, I'm saying 800 to 770 is 30, and then it's 8 more down to 762, so that's how I get to 38. And then from 800 to 801 is 1. All right, so mental math there. 78D equals 39. And then I divide both sides by what? 78. And then I go, wait a minute. Those two numbers, are they related at all? Sure enough, 2 times 39 is what? 78, right? 2 times 39 is 78. So then 39 goes into 39 once and 78 twice, so this is 1/2. Oh, wait a minute. But I don't want to give it in a fraction form. I want to give it in the decimal form. So what is 1/2 in a decimal form? 0.5, right? Don't forget the decimal, 0.5. Or you can say 0.5. But don't say 0.05. That's not right. No, that's not right. So 0.5 or 0.5. But decimal form there. Since 1/2 and 0.5 are exactly the same thing, my students can tell me 1/2 or 0.5. But again, typically if you're given decimals, you give the answer in decimals. All right. So 1/2 is 0.5. Let me make sure you can see the decimal real good right here, because it's kind of just this little dot on the screen here. All right. The decimal's got to be there. And this one, I just did something as crazy as I could think of. I gave you, look, your x on the left, 3.75x, that's 2 decimal places. Minus 5.1, that's 1 decimal place. Equals 2.025, that's 3 decimal places. Minus x, that's no decimal places. I mean, really? Not a single one of those terms is alike in the sense of a number of decimal terms. There are like terms, there's decimals, there's whatever, but not like in that sense. So, did I use yellow on the last page? Yes. So let me go to the next color here. I need to move the decimal places how many places? What's the most decimal places? 3. So I've got to move it 3 places. So I got to go 1, 2, and then a third one, which means I got to add a 0. 3750x minus 1, 2, 3. I got to move it and add how many zeros? 2 zeros. Minus, move it 3 places. Do I add any zeros here? 2025. No zeros added, right? Because I didn't go past what I was going there. Over here, this is like a 1. Move it 3 places. So I got to put in there what? Minus 1000x. Okay? Got to put 3 zeros in there because I moved the decimal place 3 times and there was no decimal there. And I left off my equals, or either it took it away. I probably just left it off. 3750x minus 5100 equals 2025 minus 1000x. So now what do you want to move? Doesn't matter. I'm going to move my 1000x. So I'm going to add 1000x to both sides. And when I do that, that cancels and I get 4750, right? X minus 5100. That's not 5100. I got an extra 1 in there. 5100 equals 2025. And then what do? Now I add my 5100 to both sides. And so 4750x equals 7,125. Is that what that is? And then I divide both sides by 4750. And x equals, and here, look, if you don't have a calculator handy, then you can either try to simplify that, or you can come out here to the side, since you're doing a decimal anyway, and say 7125. Oh. How many times will 4,750 go into 7? It won't. 71. 7. Nope. Right. It has to go all the way into 7,125. It's going to go one time. 4750. Going to subtract. And then we got to figure out what that is. So we're going to say this is going to be 5. You're going to borrow 1. 12. It's going to be 7. That's 0. You got to borrow 1. It's going to be 3 and 2. So 2375, and then you got to have your decimal, right? Your decimal's got to come straight up here. You're going to add a 0. You're going to bring down the 0. How many times is it going to 23,750? Let's say 5 times and see what happens, because 5 times 4 is 20. 5 times 4,000 is 20,000. 5 times 7 is 3,500. Hey, that looks pretty nice. I think that's going to be exactly that number. And then subtract and you get 0, so then you're done. So let's just check that with the calculator to see. And if you have a calculator, you just punch it in, you're done. But you can go old school with the division over there. All right, the numbers got kind of big. Let's see. Well, I can't type. 7125 divided by 4750. 1.5 indeed. 1.5 indeed. All right. So hope this helps out when you have decimals. Again, it's more of a preference. Decimals are just fractions. You can multiply by 10 or 100, but and again, this one was just wild and crazy, right? But again, I wanted to give you a wild and crazy one here at the end to expose you to it, let you see it there. All right.